Hello, first-year high school students. I'm Math Supergod. Let's go over the second monthly exam that just finished, the one after the midterms. I'm going to review it for everyone. The first question is a test on our set operations. It says, set A is 0 and 1, and set B is 0 and -1. Now we need to find the union of set A and set B. That means we just list all the elements to form a new set. That's all. Intersection is for the overlapping elements. So in this case, we have 0, 1, and -1. This means we should choose option B. Okay, let's move on to the next one. The second question. The second question is a test on what we call logarithmic operations, or rather, a test on the definition of a logarithm. It doesn't involve too many operations. Of course, if you want to think of it as an application of the change of base formula during this process, that's perfectly fine too. Either way works. Okay, so this means that when we get this expression, we can rewrite it. 32 can be written as 2 to the power of 5. And 64 can be written as 2 to the power of 6. The reason is that 64 is 8 squared, and 2 to the third power squared is 2 to the 6th power. So based on a corollary of the change of base formula, if both the base and the argument are in the form of a power, you can bring the exponents out to the front. When you do that, the exponent from the argument goes in the numerator, and the exponent from the base goes in the denominator. So that means it equals 5 over 6 times the log base 2 of 2. And since log base 2 of 2 is exactly 1, the final result is 5 over 6. Okay, next. Given that sine theta times cosine theta is greater than 0, so what does being greater than 0 imply? Being greater than 0 leads to this conclusion. It means that sine theta and cosine theta are either both positive or both negative. Which means they have the same sign. Okay, so if they have the same sign, then as we know, in the first quadrant, everything is positive, so this means it could be in the first quadrant. In the second quadrant, sine is positive. So if sine is positive, cosine is negative. So it can't be in the second quadrant. In the third quadrant, tangent is positive. If tangent is positive, it means the remaining sine and cosine, sin and cos, are both negative, so it could be in the first or the third quadrant. Okay, and now the absolute value of cosine theta is equal to cosine theta. That means the absolute value of a number is equal to itself. So in this case, this cosine theta must be at least 0, or it could be positive. In this case, in the first or third quadrant, it can't be 0, so it can only be positive. So this means cosine theta is positive, which means it can only be in the first quadrant. Therefore, we choose option A. Okay, so we just determined it's either in the first or third quadrant. And since our cosine theta can only be positive, that means we've locked it in. It can only be the first quadrant. Okay, next is a question about finding a function's value given its parity. Okay, fx is an odd function defined on R. When x is greater than 0, the analytical expression is given to us. We could find the expression for when x is less than 0, but it's not necessary. Because when we find f of -1, according to the property of odd functions, it must be equivalent to the negative of f of 1. So this means we only need to calculate f of 1. For f of 1, 1 squared is 1, plus 2 times 1 is 2. The final result is 3. So f of 1 equals 3, then negative f of 1 is -3. This means the option we choose is A. Okay, the next one is a comparison of magnitudes. It has both logarithmic and power structures. The core idea we should use is to find an intermediate value in this process to help us compare the magnitudes. That will be enough. Okay, for this value, the logarithm of 4 with base 3, log base 3 of 4, at this point we must consider numbers like 0 and 1. 0 is log base 3 of 1, and 1 is log base 3 of 3. So this means this value must be greater than the logarithm of 3 with base 3, which is log base 3 of 3. And log base 3 of 3 is exactly 1. At the same time, can it reach what we call the logarithm of 9 with base 3, log base 3 of 9? Obviously, it can't reach that, right? Because log base 3 of x is monotonically increasing. Log base 3 of 9 is exactly equal to 2. So this means the value of a is 1 point something. Next is b, ln of 2. For ln of 2, we can briefly remember that it's approximately 0.69. We can also judge by its magnitude. So b, this value is definitely greater than what we call ln of 1. ln of 1 is exactly 0 because ln of x is also monotonically increasing. At this point, we need to remember the value of the base of the natural logarithm, e. It's approximately 2.71828. Okay, 2.71828. So this means ln of 2 is definitely less than ln of e, and ln of e is equal to 1. This means the value of b is between 0 and 1, which is 0 point something. As for our c, 5 to the power of 1/2 is the square root of 5. And the square root of 5 is definitely greater than the square root of 4. The square root of 4 is 2. So this means the number c is greater than 2, the number a is between 1 and 2, and the number b is between 0 and 1. Therefore, c is the largest, followed by a, and b is the smallest. So we have c is greater than a, which is greater than b, c is greater than a, which is greater than b. Thus, the option we choose is a. Okay, the next one is based on the monotonicity of a piecewise function here to find the range of the parameter. We must firmly adhere to 2 key points. One is that each piece must be monotonically increasing. For the piece, 4 minus ax plus 7, this linear function requires that the coefficient of the linear term, 4 minus a, is greater than 0. Then the second piece is an exponential function. For an exponential function to be increasing, its base must be greater than 1. Secondly, at the connection point at x equals 2, there will be an inequality relationship for the function values. The function value on the left side must be less than or equal to the function value on the right side. The left side is 4 minus a, let me write it more clearly, 4 minus a. Okay, then times 2 plus 7 must be less than or equal to the value here when we plug in 2, which is a squared. The first one is relatively simple to solve, so it's 4 minus a is greater than 0, so 4 is greater than a. This means for the first one, a must be less than 4. For the second one, a must be greater than 1. This third one is a little bit more troublesome. Move everything to the right side. That is, 0 is less than or equal to a squared. Negative a times 2 is negative 2a. If we move it over, it becomes plus 2a. Then 2 times 4 is 8, and plus 7 is exactly 15. Moving it over, it becomes minus 15. So in this case, the right side can be factored as a plus 5 times a minus 3. 0 must be less than or equal to it, which means it must be greater than or equal to 0. So in this case, we should take the values on both sides. This corresponds to a quadratic inequality. To solve this quadratic inequality, the parabola opens upwards. The left root is negative 5, and the right one is 3. By solving this, my a is either less than or equal to negative 5, or a is greater than or equal to 3. Now, since the range for a we got earlier is greater than 1 and less than 4, it definitely can't be less than or equal to negative 5. So it must be greater than 1 and less than 4, and also satisfy being greater than or equal to 3. So you can draw a number line, or during this process, you can take the larger of the lower bounds. It must be greater than or equal to 3, and also greater than 1, so it must be greater than or equal to 3. And it's also less than 4, so in the end, we choose option 4D. So in this process, if you find it a bit slow to calculate the intersection that satisfies all inequalities simultaneously, or if your accuracy isn't very high, you must remember to draw a number line. You must remember to draw a number line, okay? Let's give it a try. One part is less than 4. Let's use different colors. One part is greater than 1. This is greater than 1. Another case is less than or equal to negative 5. Less than or equal to negative 5 is at this position. Okay, it can be equal to it. This is negative 5. The other one is greater than or equal to 3. It's roughly like this. You need to find the part where all 3 colors overlap. That would definitely be just this part, right? So this means it's greater than or equal to 3 and less than 4. Okay, next is a test of the zero-point existence theorem. The test of the zero-point existence theorem is that when we substitute the endpoints to find the function values, if one is positive and one is negative, then we have found the interval where the 0 point is located. Okay, substituting 0 is a bit troublesome. Some students find it hard to calculate the limit. Don't worry, let's try substituting 1/4 from this position to start. So this means we calculate f of 1/4, which equals 1/4 minus the logarithm of 1/4 with base 1/2, and then plus 1. So in this case, what is the logarithm of 1/4 with base 1/2? To what power must 1/2 be raised to equal 1/4? The square. That means it's exactly 1/4 minus 2 plus 1, which is 1/4 minus 1. This is exactly equal to negative 3/4, which is less than 0. Okay, next, let's plug in 1/3. At this point, you'll find it's exactly 1/3 minus the logarithm of 1/3 with a base of 1/2, and then plus 1. Okay, so now that we have this structure, let's process this data. Let's simplify it. 1/3 plus 1 is exactly 4/3. Then we subtract, and here we can use our logarithmic operations. When both the base and the argument have a power structure, which are 1/2 and 1/3, or 2 to the power of negative 1 and 3 to the power of negative 1, we bring the powers out front. Then it can be written as log base 2 of 3, because negative 1 over negative 1 cancels out. Now, we want to do what with the term in front? We want to convert it into a logarithmic structure as well. So at this point, it can be written as log base 2 of 2 to the power of 4/3, which is exactly 4/3. You must know how to do this operation. Then subtract log base 2 of 3. And when we get this structure, our main goal is to compare the size of 2 to the power of 4/3 and 3. So we've provided a method called the exponent amplification method. The exponent amplification method, this means we raise both sides to what power? The third power. That's equivalent to comparing 2 to the power of 4/3 raised to the third power, which is 2 to the fourth power, with what? With 3 to the third power. 2 to the fourth power is 16, and 3 to the third power is 27. 16 is less than 27, so 2 to the fourth power is less than 3 to the third power. This means 2 to the power of 4/3 is less than 3. Therefore, the result of this operation is less than 0. It's still less than 0. So this means next we'll solve for 1/2. So at this point, f of 1/2 is exactly 1/2 minus the logarithm of 1/2 with a base of 1/2 plus 1. The logarithm of 1/2 with a base of 1/2 is 1, so we have minus 1 plus 1, which cancels out. It's exactly 1/2, which is greater than 0. So this means the function value at 1/3 is less than 0, and the function value at 1/2 is greater than 0. Therefore, the interval must be between 1/3 and 1/2. And so we choose option C. Hey, you must pay attention during this process. This part essentially tests your ability to compare sizes. So how do we compare the size of a power and a number? When we see this fractional exponent power structure, we consider using the exponent amplification method to handle it. Okay, the next one is about identifying a common graph. As I've said, this can be tested in various major exams, including real questions from the Gaokao College entrance exam a few years ago. So it's a frequently tested topic. When we get this, we have a few entry points. One is the domain, another is the parity, and also the function value. So we know that the absolute value of log x, the numerator, is what kind of function? An even function. The denominator, which you are required to remember, is what kind of function? An odd function. An even function divided by an odd function results in an odd function. Since it's an odd function, we can directly eliminate option C. If we take a closer look, we'll find that option D is also incorrect. Option D is incorrect. Okay, so this means because the graph in option D is not, look here, it's not symmetric with respect to the origin. So we choose between A and B. All right, the main difference between A and B is in observing the graph. Observe the graph. It's that in this process, we substitute, for example, a value between 0 and 1. That's the function value we need to find. For a value between 0 and 1, you'll find that for option B, it's negative. The corresponding function value is negative. Whereas for option A, the corresponding function value is positive. So this means that at this point, we just need to find f of 1/2. Now for the numerator in this position, the absolute value of 1/2 is 1/2. The denominator is 2 to the power of 1/2 minus 2 to the power of negative 1/2. All right, 2 to the power of 1/2 is the square root of 2. So let me ask you, the square root of 2 minus 1 over the square root of 2. 2 to the power of negative 1/2 is 1 over the square root of 2. The denominator must be positive because the square root of 2 is 1.414. All right, the value in the numerator is log of 1/2. Log of 1/2 is definitely smaller than log of 1, which means it's less than 0. The numerator is a negative number and the denominator is a positive number. So a negative number divided by a positive number, the result is a negative number. This means the function value at 1/2 is negative. Therefore, we choose option 2b. There, no problem. So this means that when we get this type of problem, we can handle it from these three directions. The domain at this stage, the parity, and the function value. Handling it by the function value, right? Okay, then let's look at this multiple choice question. For the multiple choice question, when you get it, it tests. Question 9 is a test of our trigonometric functions, a test of trigonometric functions. Okay, let's take a look. If angle alpha is an acute angle, then angle 2 alpha is an obtuse angle. We know that an acute angle alpha has a range. It's greater than 0 degrees and less than 90 degrees. So if we multiply it by 2, 0 times 2 is 0 degrees, and 90 degrees times 2 is 180 degrees. I can only get its range between 0 degrees and 180 degrees. So is it necessarily an obtuse angle? Not necessarily. It could be an acute angle or it could be a right angle. Negative 4 pi over 3 is an angle in the third quadrant. So when we get to this point, let's take a look. Draw a diagram yourself. If you have a negative angle, it means you must rotate clockwise. So this position is 0. The negative direction of the y-axis is negative pi over 2. The negative semi-axis of the x-axis is negative pi. You want negative 4 pi over 3. So it's roughly at this position, still negative. So that means it should be in the second quadrant. Hey, 4 pi over 3 is in the third quadrant, no problem. The negative one is in the second quadrant. The central angle is pi over 6. Well, since this is a multiple choice question, the answer must be C and D. Let's verify it. For this sector with a central angle of pi over 6, the arc length is pi over 2. We need to find the area of this sector. So in this case, the central angle is equal to the arc length divided by the radius. You must remember this formula. So that means if we plug in the values, we get pi over 6 is equal to the arc length, pi over 2 divided by the radius, pi over 2 divided by what equals pi over 6. The radius must be equal to 3. Okay, for the area S, let's use the formula. It's 1/2 times the arc length times the radius. So we have 1/2 times the arc length, pi over 2, and then times the radius, 3. The result of the calculation is exactly 3 pi over 4. No problem. Okay, for a sector with a perimeter of 20, when its area is maximized, it says the central angle is 2 radians. So in this case, based on its perimeter, let's call it C, the perimeter of the sector is equal to 1 arc length plus 2 radii. If you draw a quick diagram, you should be able to see it. A sector has 1 arc length and 2 radii. Okay, so the result of that is 20. And my area S is 1/2 times the arc length times the radius. So if we substitute, it's 1/2 times L, which is exactly 20 minus 2R, and then times what? Times R. So after simplifying, it's exactly 10 minus R times R. So this is exactly what kind of function of R? A quadratic function, plus 10R. So it opens downwards, and the axis of symmetry is negative B over 2A. Which is exactly when r equals 5. When r equals 5, we get the maximum value for our area. We can calculate it. It's exactly 50 minus 25, which is 25. In that case, my arc length should be equal to 20 minus 2r, which is exactly 10. From that, we get my central angle alpha, which is L over r, and that's exactly 10 over 5, which equals 2. No problem. So option D is also correct. Okay, next up is a test of basic inequalities for this part. Hey, there are many methods, given that a and b are both positive numbers, and a plus b equals 1. Now we need to find a times b. We know that for a fixed sum, the product has a maximum value. AB is less than or equal to the square of a plus b over 2. If we plug in the values, it's exactly equal to 1/4 in this case. No problem. So that means option A is correct. Okay, next let's look at option B. Since AB has a maximum value, let me ask you, what must the logarithm of AB with base 2 be? It must be less than or equal to the logarithm of 1/4 with base 2, which is exactly equal to negative 2. So it should be less than or equal to negative 2. Okay, and then 2 to the power of a plus 2 to the power of b. Now I already know that the sum of the exponents is a constant value. This means that based on one thing plus another thing, it must be greater than or equal to 2 times the square root of their product. Their product is 2 to the power of a times 2 to the power of b. Isn't that just 2 times the square root of 2 to the power of a plus b, which is 2 to the power of 1, right? And the square root of 2 to the power of 1 is the square root of 2. So it's 2 times the square root of 2. This means that 2 to the power of a plus 2 to the power of b has a minimum value. But it's not 4, it's 2 times the square root of 2. So option C is incorrect. B and C are incorrect. It's a multiple choice question, so that means D must be correct. We have our answer, which is option AD. What is the minimum value of 1 over a plus 2 over B? Well, there are many methods. Let's just multiply them. I'll demonstrate it again. 1 over a plus 2 over B, what do we multiply it by? We multiply it by a plus B. Since we're multiplying by 1, we can ignore it. Let's expand it. 1 over a times a is exactly 1. 2 over b times b is plus 2. Then add 1 over a times b, which is b over a, and 2 over b times a, which is 2a over b. So at this point, it's greater than or equal to 1 plus 2, which is 3 plus 2 times the square root of their product. 3 plus 2 times the square root of 2. No problem. If we directly use the Cauchy inequality, it's greater than or equal to a bunch of squares. 1 over a times a is 1, 2 over b times b is 2. Taking the square root gives the square root of 2. The result of the calculation is exactly 1 squared plus the square root of 2 squared, which is 3 plus 2 times the square root of 2. Then there's also something called the power mean inequality. So for this calculation, when you see the fractional form, it's directly greater than or equal to the sum of the denominators in the denominator, and in the numerator, 1 can be written as 1 squared, and 2 can be written as the square root of 2 squared. So that's 1 plus the square root of 2 squared. The result is 1 over 1 squared, plus the square root of 2 squared, which is 3 plus 2 times the square root of 2. All roads lead to Rome, which means I've demonstrated the basic inequality, the Cauchy inequality, and the power mean inequality for everyone. So this means let's take a look. Okay, the next one is about judging a proposition. Of course, in this process, it's because it tests a lot of things. It covers various aspects. The first one is, note that it's asking for the incorrect one. It says for any x in R, this expression is less than 0. The negation of for any is there exists. No problem. x0 is in R. 3 times x0 squared minus 2 times x0 minus 1. The less than should become what? Less than should become greater than or equal to 0. It's greater than 0, so it's incorrect, which means the answer is not correct. Next, let's look at option B. It says the graph of this function always passes through the fixed point 4, 2. So in this case, for fixed point problems related to logarithmic functions, we just need to let the argument be 1. The argument must be 1, so x minus 3 is 1, which means x is 4. The x-coordinate is correct. Log base a of 1 is 0, 0 plus 2 is 2. The y-coordinate is also correct, so it always passes through the fixed point 4, 2, correct. Okay, option C. The monotonically increasing interval of this function is from 1 to positive infinity. So when we get it, we can break it down into an inner function and an outer function. So the inner function t is equal to x squared minus 2x minus 3. Since it's in the position of the argument t must be greater than 0, then y is equal to log t. Now for this quadratic function, you need to make this quadratic structure greater than 0, which means we need to factor it. X minus 3 times x plus 1. Take a look for yourself, it's correct. Okay, it needs to be greater than 0, so that means it opens upwards. One root is negative 1 and the other root is 3. To be greater than 0, we take the two sides. In that case, your x is either less than negative 1 or greater than 3. Can it be from 1 to positive infinity? That's not right. Okay, I know that this quadratic function is monotonically increasing from 3 to positive infinity, and our outer function y equals log t is definitely monotonically increasing. An increasing function of an increasing function is increasing. So it's not from 1 to positive infinity, but from 3 to positive infinity. It overlooked the consideration of the domain. Okay, next one. This inequality in x holds for any real number x. So since it holds for all real numbers x, we're asked to find the range of k. So when we look at it, the left side can be seen as a quadratic function. The graph of this quadratic function could be above the x-axis. It could have one common point with the x-axis, or it could have two common points. For it to always be greater than 0, it can only be the first graph. The second and third are incorrect. So we use the delta method. Delta just needs to be less than 0. Delta is equal to b squared, which is negative k squared minus 4ac. It's required to be less than 0. So there's no common point with the x-axis. It's always above the x-axis. So in this case, solving it, we get that k squared must be less than 4, so k must be greater than negative 2 and less than 2. So that means our option D is correct. So in the end, the incorrect ones are exactly options A and C. Okay, next let's look at the fill-in-the-blank questions. For the fill-in-the-blank questions in this process, there's also a test on trigonometric functions. For example, the first one is a test of the tangent value. The tangent value, when we get it, is equal to the y-coordinate divided by the x-coordinate. That's all. It doesn't matter if it's the intersection with the unit circle or a regular point on the terminal side. So that means the result of the calculation is the y-coordinate 1 over the x-coordinate negative 2. So the final result is negative 1/2. This is a giveaway question. Okay, the next one is a test of calculations related to logarithms. It says blood oxygen saturation is blah, 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 a bunch of stuff. The normal range is this much. When it's below 90%, oxygen therapy is needed. We can use an exponential model, where s of t equals s naught times e to the power of kt. We get this relationship. It will change with the change in the oxygen administration time t. Here, S naught is the initial blood oxygen saturation, and K is a parameter. It's known that S naught is 60%. So we can substitute it in. After 1 hour of oxygen, the blood oxygen saturation is 80%. This way we can solve for K. Let's give it a try. Okay, after 1 hour, it's 80%. As we read this, we'll set up the equation. Then it equals our 60% S naught times e to what power? Kt. T is now 1, so it's K times 1. Okay, so if we do that, we divide by 60%, and the result is exactly 4/3. So it equals e to the power of k. So that means our k is equal to the natural log of 4/3. Okay, for a precise calculation, we won't rush to calculate the value of K. You must pay attention. You must pay attention. Okay. Then next, to get the blood oxygen saturation to reach 90%, the question is, what is the minimum additional oxygen time needed? You must pay attention to the word additional. This means it has already reached 80%, and I want to reach what? 90%. So this means that in this process, you must think clearly. Now we want to reach 90%. So at this time, it's equal to starting from 60% times e to the k. What is k? The natural log of 4/3 times t. Okay, so that means we have this structure, and we'll work with it. Note that this t is the total time from the start, so you have to be clear-headed. Okay, so in that case, I'll divide by 60%, and that gives me 9/6. And at this time, it's equal to our... let's look at the right side. What can we rewrite the right side as? That is e to the power of the natural log of 4/3 times t. That is e to the power of the natural log of 4/3. What can we rewrite it as? We can rewrite it as our 4/3 to what power? To the power of t. Okay, so it's our 4/3 to the power of t. Okay, so what data are we given now? The data we're given now, what is its base? It's base e, which means ln2 and ln3. So this means when I get this data, I can first simplify 9/6. If we simplify it by a factor of 3, it becomes exactly 3/2. Then, at this point, we can take the logarithm of both sides. What base should we use? We'll use base e to take the logarithm, that is, take the natural logarithm of both sides. This reduces the power. We take the logarithm of both sides to reduce the power. Okay, so by doing that, we now have the left side is ln of 3/2, and the right side is ln of 4/3 to the power of t. We can move the t directly to the front. Whenever you have a power exponent, you just move the exponent to the front. So that means we have ln of 3/2, and it is equal to t times ln of 4/3. So this means the t that we want is equal to our ln of 3/2 divided by ln of 4/3. Okay, so now let's process this. The numerator is equal to our ln3 minus ln2. For the denominator, it's ln4 minus ln3. And ln4 is 2 times ln2 minus ln3. So at this point, it's approximately equal to, in the numerator, it's 1.10 minus 0.69. In the denominator, it's 2 times 0.69 minus 1.10. So that means, for the numerator, 10 minus 9 is 1, and then 10 minus 6 is 4, so that's 0.41. In the denominator, 2 times 9 is 18, so that's 1.38 minus 1.10, so we have exactly 0.41 over 0.28. So you just do 41 divided by 28. The quotient is 1, which is 28. What's the remainder? 13, right? Okay, so it's 1 point something, right? Is 5 enough for the next digit? 5 times 8 is 40. No, let's try 4. 4 times 8 is 32. This is a 0. 4 times 8 is 32.